students, back in the lab again to look at the second half of OS4. I'm wearing my new favorite shirt. Bonus points on the next test if you can correctly identify all of the species seen on my shirt. There are some hints here. Also, I will tell you that I've seen all of these in the wild in person except for one, so that might be helpful. But anyhow, we're going to look at 4 and 5. So 4 and 5, as you might have noticed, are a little bit more challenging than some of the ones on the front page of OS4. And you can still do these, right? So think about those things that you are keeping in mind when you're solving these exercises. Let's look first at number 4. Wow, this looks very much different than that. And part of the reason why it looks different is the skeletal structure is different. Here you have 4 carbons, and then an ester linkage, and then 3 more. And then over here, all 7 of those carbons are connected to each other. So we know that we're going to have to pull this molecule apart and stick it back together, right? We don't have to do alkene oxidation because we don't actually have to rip apart carbon-carbon bonds because we have this ester linkage. But here, we're definitely looking at Grignard, right? Let's think about retrosynthesis for a minute. What was the last step in forming this? It could have been Grignard. Here's a clue. What is this? That's right, it is a tertiary alcohol. A tertiary alcohol suggests to us that if this was Grignard, we had a ketone reacting with a Grignard reagent, right? So we might think about what was that new carbon-carbon bond that was formed there. Remember, they usually form near where the alcohol group is connected. So it's probably one of these 3 carbon-carbon bonds was the new one. Over here, I have a group of 4 carbons and a group of 3 carbons. So that might give us a hint. It is in fact this one, right? That is the new bond that got formed, right? And remember how Grignard works, right? This part used to be the Grignard reagent, and this used to be what? Right now it's a tertiary alcohol, but it used to be, that's right, a ketone. And now that gives us some clues, right? Now we can sort of figure out what's going on. So first step, we want to pull this apart. Again, we have a couple options for breaking esters. You can play around with them. In this case, I think powerful reduction is going to be the easiest with lithium aluminum hydride. You can use ester hydrolysis too. It's just going to, I think, give you an extra step. So powerful reduction is going to cut this thing apart. And we're going to get this. Remember, we want to convert this thing to a ketone, so we're going to isolate these 2. You don't have to do it all in one pot, so separate those out. And on the small molecule, let's use PCC, right? That is gentle oxidation. You could use powerful oxidation too, same difference. And that will give us this. And now we just need to convert this into a Grignard reagent, right? So we need to make it into a halogen, bromine or chlorine. So in the larger molecule, let's use HCl. That's a little SN2. Right, that will give us this. And now we're going to prepare the Grignard reagent. Magnesium with ether. Right? If I treat this with magnesium and ether, I will get this. And now we can react these 2 things together, right? So the 5th step is the one we were looking at over here, is actually Grignard. Remember, once you combine these together, you form this bond. Originally, you'll actually get this, the alkoxide step. And it would be nice if you show that last step where you take this and react with H2O with water. And that water will donate an H plus and give that to the O8, to the O minus and reform the alcohol. So that's number 4. Let's take on number 5 for a minute. Number 5, at first, you look at that and you're like, right, way different. But relax, don't panic. All right, remember, let's think about counting carbons. Let's look to see, has our carbon skeleton changed? Our gut reaction is, heck yeah, it has, because there's a lot more carbons over here, right? So over here I have 1, 2, 3, I have 4 carbons. And over here, I have 1, 2, 3, 4, 5, 6, I have 8 carbons. So I know I'm gonna need more than one molecule of this, and that's how we roll in chemistry. We don't usually roll with one molecule at a time. So assume you start with a whole flask or a whole beaker of this, so you have all of these that you need. If I start with 4 carbons and end with 8, that suggests something to me, right? That suggests that maybe two of these put together will make that one, right? There are a whole bunch of new carbon-carbon bonds here, and carbon-carbon bonds, brand new ones, suggest to me our good buddy Grignard. So I know probably we did Grignard here. Are there any other clues for this one that we actually used Grignard? Actually, yes, there are, right? What are some other clues? Well, here's our good buddy tertiary alcohol, right? And oftentimes we have secondary and tertiary alcohols when we have Grignard forming. So, a question is like, how did this molecule come together? Maybe it came together like this, where we have 1, 2, 3, 4 carbons and 1, 2, 3, 4 carbons, and it came together like that. That's not a bad idea. There's some evidence for that maybe over here, but check out over here. Remember when new bonds are formed in Grignard, they almost always leave an alcohol group. And there's not an alcohol here or here. Okay, so that tells you can play around with this a little bit, but probably the molecule did not come together this way. What if it actually came together this way, where this was one group of 4 carbons and this was a second group of 4 carbons? If that were the case, right? Notice the site in which they came together in both cases has an OH, a tertiary alcohol. So what if this were really this? And this were what, right? If this is a Grignard reaction, here's our C double bond O, this side would have been our Grignard reagent, right? So a little bit of retrosynthesis suggests that maybe we had something like this. And then over here on this side was so our last step. If our last step is Grignard, that's our hypothesis. We need to make this and this. Now suddenly, those things don't seem nearly so daunting to make from this. Right? Now we can say, well, how can I get this into this? If you add, let's say, some number 1, some HBr. We don't want anti-MEA, right? Because we actually want, we'll start with half of our, we're going to pour off half of this and treat it with HBr. That will get us to this. Remember in MEA, when you add HBr, you're only adding 1 bromine per double bond, and we have 2 double bonds, so we're still going to end up with 2 bromines. So we get that, and now, plus Mg in the presence of ether gives us this. And the question is, how do we get that? We're going to take the other half of this and react with H2O. This is also, that we can call this 1A. For 1B, we're going to take the other half, and we're also going to do MEA, H2O in the presence of H+, right? That's going to give us this. No, we are dangerously close to that, right? All we have to do is some oxidation. Your choice, gentle or powerful, both will do the same thing. If you add PCC or dichromate with acid, you'll get this dione. This is butadione, 2,3-butadione, and now we have the other half for that. See? Not so bad. Nice job. You did it. Keep it up.